use. So energy efficient technologies on the way to plus energy buildings is my topic. And I don't know why it's not working. This one here, it's on. Yeah, it's on. So first I would like to tell you what I'm doing. I'm in one side of my life, I'm an engineer, and maybe in the meantime 50% architect. And let's say I have nearly 100 engineers working around me, so we're doing real projects. And the other side of my life is I'm a professor in university, and this is very important for me that I could not teach on a university. I never built buildings. So this is very important for me that I'm totally in the business, in the practice. Otherwise, I only teach simulation and teaching from books, and I don't know. So I need to really build buildings to learn what's really happened and to try new technologies. And we have an office in Stuttgart, in Brunswick, and in North Germany. And what's also very important for me is to export our knowledge in the world. So I was very early maybe 10 years ago, I teach very often in the Tongji University in Shanghai, and there also we have now an office there with nearly 15 people, and we're trying to do projects. But I tell you, it's very hard to work as a small German enterprise in Shanghai, in this huge city. But now it's nearly that we have not more red numbers in our book, so it's now still established. And also in Dubai we are working a little bit. Before I starting with our projects in Germany, so this is one of an example. Also, we're doing the first DGNB projects in China. It's very hard also to compete against LEED because LEED is worldwide established, and Germany slept a little bit on this topic. I have to say that because I'm very long around also in the States. So this is one of the first DGNB project in Pudong, and it's now under construction, and so we try to transfer the German, let's say, basic approach for DGNB labeling, sustainable labeling on. We cannot transfer it in the language, but we have to consider what happened, the Chinese codes and all the Chinese material. Then also what I'm doing as professors, this is one of a nice project I would like to mention. It's a student work. We work together with the Tongji and the Lanzhou University and make a student competition on a city, let's say in a city scale, and we present that by the Expo 2010. It was for our students a great challenge to work together with students from Tongji and from our university. So this is our Ministry of Construction, Dr. Ramsauer, give there the honor and to present then the winners that get his certificate from him. So this was a little bit about what I'm doing, buildings and teaching, and this was a very interesting student work. So now coming to the topic. The topic is, let's say, the way to the plus energy building. So this is nearly more or less my life. So I starting 72 in solar, and you see on the left, you see that, by the way, the oil price, the fiber curve of the oil price, and similar to this is, let's say, the buildings where nearly development. So we're starting very early in the 70s with the first solar houses. We call them solar houses, mainly on solar thermal and big storages in the houses, but to this time PV was not as developed as now. And then we're starting with more or less glass houses, and we starting with energy autonomous houses. And then we build huge solar dwellings. Let's say we thought it's making more sense to build a big storage and put all the buildings around this big storage, because we collect solar in the summer. We have in Germany this typical climate. You need have a lot of solar in the summer, and we have the heating in the winter, from quite different to here. And so we thought it's good idea to build huge big storages underground to get this cost advantage and all these things. And then this is this big storage. We built maybe 10 projects on larger scale. And then after this, we learned a lot about these things. We learned, for example, that simulation is nice, but practice is much better. And we learned a lot of audit. You speak about also audit. We do a lot of monitoring. This is one of the things what we're doing in Germany is that we're monitoring everything, and we show we make the energy efficiency transparent. This is a very important thing to learn what you have done. And then in the last years, we're doing more, let's say, buildings we call it Energy Plus buildings. So this is, I would like to show you 2 or 3 of these buildings. The way to what we're doing is at the moment we are thinking also on this, what people are asking about Energiewende in Germany, that our energy supply is mainly on central stations, on huge nuclear power stations, coal stations, and so on. And then the idea is to go to smart grids, is to decentralize the energy production, to make more and more smaller scale cogeneration plants, and to go more and more renewables. Because the goal is to 2050 to have 50%, 60% renewable energy supply of the whole city, of the whole country, not city, of the whole country. So the idea is smart buildings in the smart grid, and also on the sense of the mobility we have to change in the more or less coming from the fossil supply to the more or less maybe electricity and hydrogen supply systems. What means Energy Plus? It means from the energy consuming building to an energy generating building. But the much more challenge is, this is on yearly basis, much more challenge is on the lifetime. And the lifetime, if you have during your building needs a certain energy to produce. And the king challenge, let's say the challenge is during the lifetime of a building, that the energy who is needed to produce the building, that you get more energy back over the lifetime. This is the king challenge. I say this is the prime challenge, the real challenge. And this you see in this picture here. You see in this picture that normally this is the energy you need to build the building. And normal buildings, also very good passive buildings, low energy buildings, they need. And if you accumulate this energy, you will never have an energy payback time, never. And the plus energy building means in the sense that over the lifetime, you have a surplus during the year, and if you accumulate all the surplus, then you get a certain time of, let's say, energy payback. I call it energy payback time. I don't know if this is the right translation, but I call it as time of return for an energy. And this is one of this building. Maybe I show you some pictures of this one. No, this in this direction. Okay. This I wrote a book about. It's now will be published also in English and Chinese in January. It's now available since 2 weeks in German language, and in January 2013 it will be available in English and in Chinese language. So I will show you 3 projects: the 2 commercial buildings and 1 residential one. I have to look on the time, and so maybe some of the slides I will skip. So this is one of the project. The first we have done in this Energy Plus was the headquarter of a solar company in Berlin. It's called Solon. And the main feature of this project was that the whole energy supply is on renewable. You see it's based on PV, on roof or building integrated PV, as well as on biomass, as well as on waste energy. And this is the waste energy, and the biomass is combined in a cogeneration. So we have a cogeneration, we have a heat storage, we have the heat who is exhaust from the cogeneration is used for cooling by an absorption cooling machine, and is also combined with a compression cooling machine. Let me make here a remark. We engineers, we believed since many years on absorption cooling driven by heat. If you have exhaust heat, very fine. If you have solar heat, forget it. Because the PV, especially imported from China, makes a big revolution in Germany. If you're now going on cooling, solar cooling, don't believe more on absorption cooling by heat. Because the electricity from PV is so cheap that you have, as engineer, I can recommend to you, use PV and use compression cooling, and you can sleep very well. Otherwise, you have a little bit headache if you go on absorption cooling by solar. This, from my point of view, this industry they don't know it now, but they really died. Because electricity from solar is so cheap. And this is really a change in the technology. And this is the building. You see also the envelope of this building is in a, let's say, it's a wooden envelope. And this company producing modules, but now they are bankrupt due to the Chinese influence on the German market. It's happened, but it's international business. If they are not clever enough, so they are dying. But this is the building is very, very interesting. It's still now a new owner is there. But this building is the first building with surplus office buildings in Germany. Some monitoring we have done. This is the typically primary energy in typically new buildings, and you see this building have a factor of two less consumption. It's proven the design is proven in the practical operation. The second one is also a very nice building. I like this building. It's an academy. It's an academy for the world leader of inverters. Inverter, you need inverters from the PV or from the wind. You need inverters from DC to AC. And the world leader still now, I don't know how long, is a German company called SMA. I hope they will be longer, the world leader. And this company have designed, we designed for them an academy who is a surplus building, and this building is let's say based on also PV. I would not like to boring you by too much details, but you see there is a PV integrated in the roof, in the facade, as well as 3-4 movers. But in the meantime, due to that this PV drops so down in cost, movers makes no sense more. But this was the time, let's say 4 or 5 years ago, there was not happened. But then movers make sense. But now movers also died due to this low cost of PV. And also the combination is with a cogeneration based on biogas. And we have a huge electrical battery of 230 kilowatt LED battery who, let's say, to finalize the total concept. So the concept is PV combined with cogeneration. The cogeneration is used for heating, the waste heat for heating. The cogeneration and the PV is based for the electricity. But by the way, commercial buildings, the main challenge in commercial buildings is electricity. Electricity, electricity, electricity. This also we heard here for cooling, in our case for ventilation and for lighting. But we have in general we have in Germany no big cooling demand for office buildings. Not big cooling demand. But I think for here in Hong Kong, I see a big opportunity of PV and cooling. This is for me, and for dehumidification. Dehumidification and cooling, PV and compression cooling, finish. And of course, decentralized cogeneration. This is the facade. Also, the facade are, let's say, it's a PV integrated in the glass integrated in very intelligent facade with for shading, for energy producing, and so on. This is the building from the top. Residential building in Stuttgart. This is my private home. And, as an engineer, you have to, if you're not built for your own, people speaking so much about solar, they've never seen a solar collector. So I see an expert of solar is you have to take a shower with solar heated water. This is the minimum. But if you live in a house where it's totally on solar, this is totally on solar. This is 100% on solar, and it's a more or less 100%. Or I personally believe that electricity is the future. As a thermodynamic engineer, we do a lot of years about district heating, all things with heat, and also solar thermal. At the moment in Germany, solar thermal fighting, because I will show you a picture, maybe they lost this fight. Again, the PV. I never thought this before because I'm coming from solar thermal. I never thought that PV really could win against the solar thermal. This is the house. It's more or less a modern house, very, very bright, very, very open. And the energy concept also looking on the time, maybe later on we have a little bit time to discuss about the features. The main feature is electricity from the roof. I see let's say, a big future for the heat pumps, electrical heat pumps. Or in your country, it's the cooling machine. A heat pump is a cooling machine. Why? It's a reverse thermodynamic cycle. So it's the same. You combine PV and with electrical heat pump or cooling machine. Finish. And this has happened here. And the special thing is, in our case, if I can tell you, if there is no sun there in winter, still I have 2 kilowatt from the PV and 2 kilowatt with the heat pump. I get 8 kilowatt. No sun there, 8 minutes, minus 10 degrees outside, and I can heat the house. You know what has happened when you have solar thermal, by no sun on the sky, and it's minus 10? You know what's happened with the solar thermal? You have to keep them from freezing. Otherwise, it will be damaged. So this is I learned. I learned a lot in this field about, and there is a lot of things, as Mr. Katzenberg told you, it is about a lot of things of energy efficient appliances. There is a lot of management system inside, how to manage between, because the challenge is, what is the challenge? The challenge is to keep as much as possible electricity in the house. It's not to feed only the grid. This is what the policy was before. Our feed-in tariff policy. The challenge is, in the plus energy building, to keep as much as possible energy on site. And this is the challenge, the main research challenge of this house. And there is this is the house again. And this is the story I told you. What is the story? What's happened in Germany happened with photovoltaics and solar thermal. What's the story? The story is, you see, over 10, 15 years, solar thermal comes down, opala. Solar thermal comes down, hey, my goodness. Solar thermal comes down of a factor of 2, only factor of 2 cost reduction in 15, 20 years. PV is now factor of 10. It comes down in the factor of 10. And I tell you that if now we're planning PV systems, the electricity from the PV system is cheaper from the grid. It makes no sense to feed in the grid, because the grid price is higher than the photovoltaic comes from your roof. So also from economic point of view, it's better to use the electricity in your house, because it makes no sense to feed it in. So it's a revolution. This revolution has happened in the last, let's say, 12 months, maybe 1.5 years, but this revolution is there. And this is really a tremendous change. The batteries, okay, of course, the building have an electrical car. You have seen that. It's a lot of measurements I've done in this building, supported by the Ministry of Transport and Construction. There is, you see, one result is here. You see, I don't know what is. We have the building produces 80% more energy, or let's say 1.8 a factor of the produce it. And this is the consumption. The consumption is 100% is nearly 9,000 kilowatt hours, and the production is nearly 16,000 kilowatt hours per year, on-site produced. The challenge is that the self-use, or the energy is who is used. Yeah, okay, I'm finished. I know. I have too much to tell you. You know, this is my problem as a professor, also speaking. And okay, in the future. What is the future? The future will be that we have increasing this self-using energy in the house. In 2012, we increased from 18% to 30%. So this is have something to do with demand, power demand control, or power demand management, and so on. There's a lot of, for researchers, for you, we can discuss later on what I mean about power demand control or power demand. Okay. This is the house again. This is the house. Maybe you show it. So we are the engineers, by the way, for this house. So this is now, after the first family houses, now we're doing multifamily houses. Compared to your houses here, I'm a little bit shy. When I came first time, I've been in Hong Kong. And when I see all your houses, and I said, oh, what do I have to do here? I mean, I see all your huge houses. And we coming here with this one family house and this 24 or the 20 flat house, and I'm a little bit shy because I don't know how we transfer this right in your dimensions. Your maybe dimensions a factor of 100 more. The next step, what we're doing now, is after these multifamily houses, we're thinking on cities, because the challenge is not the houses, the challenge is the cities. And so we're doing some projects called smart cities of, here's, for example, it's a small city close to Stuttgart, Esslingen. So what we're trying is, this is a new area of 1,700 flats, and this is a future project, a very future project, where all buildings have as much as possible PV integrated, cogeneration integrated, and what is the challenge? The challenge is the storage of energy. And the solution will not be batteries, by the way. The solution, one of the solutions will be that we're looking on power to gas. Power to gas means that we're using the PV, and we're using electrolyzers, and we're using these electrolyzers for hydrogen, and we put the hydrogen in our existing gas grids. This is the first step, what we think what in Germany is possible, that we store the electricity from wind and PV in our gas pipelines by electrolyzers, and we can put maybe 10% of the hydrogen we can put in the gas. So in the gas, you can put 10% of hydrogen. This is the project now we have started, and we started together with these huge companies, Bosch, Siemens, and Daimler, and this is one of my, at the moment, my favorite project, looking on city scale, how to work on city scale. So, and this is my last slide, so I'm sorry a little bit long. I thought about how should be a building look like in countries like in the desert areas. You know all this Burj Khalifa, yeah? You know Burj Khalifa? This in Dubai, this huge building, 800 meters? I think this is not sustainable. And this is maybe, in this sun, it needs more area, I'm sure. I mean, this is not for your country here with the stands. But this is a house where you can put in the desert, and this house will survive by its own energy comes from the sun. Because the sun coming always there, from there. And when the house is there, the solar only penetrates the roof, and the roof is so small. So this is a solution from thinking where the sun comes, and the sun comes in this desert only from the top. And this means the building have to look like a tent. So I'm finished now. Thank you.